Hello everyone. So in today's video, I'm going to show you how to solve the heat equation using the explicit 4-point formula. Okay, so in my previous video, I've already shown you how to derive this equation. Okay, now this equation can be written in a computational molecule given as this. It's 4-point because we have 4 points. Okay, if this is my n plus 1, this is my n, and this will be m minus 1, m, and m plus 1. Okay, where for m minus 1 is my r, my m is 1 minus 2r, and this is my r based on here, and now this is the n we want to find. Now why this is 4 points? So what this happened here, if let's say I have a grid point, this is my x, this is my t, so let's divide this into whatever values of x here. If I'm dividing this into a grid points, okay, we know that this length here is my k and this length here is my h. Now if this is the origin, which is my u0, 0, now this one will be for t, or my n equals to 1, n equals to 2, and this is n equals to 0, and this is m equals to 0, m equals to 1, m equals to 2, m equals to 3, and so on. Okay, so this value here is my u00, and this value here is my u10. This is my u20, u30, u40, and so on. Okay, now this value on the end, since n is 1 and m is 0, so this one we can write as u01. This value here will be u11. This value here is my u2 because m is 2, n is 1. This is my u31, u41, and so on. Here on the other hand will be u02, u12, u22, u32, and u42, and so on. Okay, I hope you have me. Now when I say this computational molecule mean, let's say we want to find this value here. To find this value, we need this. So we need this. By combination of this will give me u11. To find u21, we need the value of u10, u20, and u30. Now to find the value of u31, we need u20, u30, and u40. And if you want to find this value u41, we need to find the previous value of u30, u40, and u50. Okay, now let's say the interval is from here to here. This value here, this point here, you can obtain from the right boundary condition. This value here, you can obtain from the left boundary condition. And all this value here, for my x value here, you can find from the initial condition. Okay, so that's the whole general solution on this grid point here. Okay, so to understand this better, let's show you one example. Okay, so let's say we want to solve this equation. ut equals to uxx. The interval is given from x0 to 1. where the initial condition is given by, okay, and the boundary condition is given by sine pi t, and u1t equals to cos pi over 2t for t greater than 0. Okay, so we want to solve this heat equation. This is my heat equation. We want to solve this using 4-point explicit method. Okay, so what is the 4-point explicit method? We have the 4-point explicit method given by m n plus 1 equals to r m minus 1n plus 1 minus 2r n plus r m plus 1 n. Okay, now what is h? Okay, the question must provide the value of h and k. Let's say it's given k equals to 0.001 and h equals to 0.1. Okay, now we know that first thing we want to do, we want to find what is r. So r equals to k over h squared, which is 0.001 divided by 0.1 squared. This will give me 0.1. Now putting into this equation now, n plus 1 equals to 0.1 m minus 1n plus 1 minus 2 times 0.1, which is 0.8 n plus 0.1 m plus 1n. Okay, now what we want to do is, if you look at let's sketch the our grid point. So our grid point now involving x from 0 to 1. Okay, if you look at the interval given here, from x is from 0 to 1. Okay, and h is 0.1. So if I'm sketching the grid point, I should have, let's do this carefully. This is my 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Okay, this is 0. Now my k here, on the other hand, okay, so this is my value here. So okay, that's good. Okay, we know that. Okay, how do you find the 0.1? Because this is my h. Okay, h. Now this is my k, where the k is given as 0.001. That's all you need to find. So we need to find all these values. All these values here. Okay, I hope you are with me. Now I told you these two value here, you can obtain from the boundary condition. Okay, the boundary condition, if you look at the boundary condition, when u is 0, t, when x is 0, t is, what's the value of t here? Okay, when x is 0, you need to find sine pi t. My t in this case will be my k. Okay. Okay, so let's find these two boundary conditions. So what is the value here? This is my u 0, 0. This is my u 0, 1. Okay, so the condition for, okay, what is u 0, 0? The boundary condition is given by sine pi t. Now t is n times k. Okay, so my t is, my n is 1 here. This is n equals to 0, n equals to 1. So 1 times 0 0.001, which is my t is 0 0.00020. Okay, so it should be 20. So let's write it again. 0 0.001. So my t is 0 0.001. So here will be sine pi times 0 0.001. Okay, make sure this pi is in radian, and you should get 0 0.0031. Okay, now for this condition, u01, sorry, this is u01. So I made a mistake again. Please forgive me. So this is my u01, because my t is 0 0.01. Now u00 is when this is 0, t is 0, which is 0. Okay, so we have obtained this value. Now we gotta obtain another value here for this one and this one. So this is my u. Okay, my x is 1, or we can say that this is my, if this is 0 0, what is this? u 10, u 20, u 30, u 40, u 50, so on. So this is u 10 0, and this is u 10 1. Okay, so they can be obtained by using this when x is 1. Okay, so this condition, cos pi over 2t. So we have u 10 0, which is cos pi over 2 when t is 0. Okay, so what do we get? We get okay, so it's not pi over 2t, it's like this. Okay, so cos pi over 2t, where t is 0, so cos 0, which is 1. And then this condition where u 10 at 1, which is cos pi over 2, and t is 0 0.001. So this will give me pi over 2 times pi 0 0.01. So it will also give me 1. Okay, so we have obtained solution for the boundaries. Now all we got to do is to find all these values here. This one, this one, this one. Now this can be found using initial condition. So u10 is my u at x 0, which is u. What is my x? 0 0.1, 0, which is I have the initial condition given by x 1 minus x, which is 0 0.1, 1 minus 0 0.1. So we have 0 0.09. Okay, so I'm running out some time here, but you can find out from here, and then u 20, the same thing, u x 0, but this is for x equals to 0 0.1, and this is for x equals to 0 0.2, where we have u 0 0.20. So we have 0 0.2, 1 minus 0 0.2, and you can get 0 0.16, and so on. So you need to find up to u 90, which is u 0.90, which is 0.9, 1 minus 0.9.